Alright, we're going to do a little bit of statistics related to Algebra 2, and if you're taking AP or Intro to Statistics, this topic of normal distributions would also be in those courses. You may be given some sort of scenario, and I'm not going to be specific with what the data is. It does need to be stated that your data is normally distributed. You might see this mu symbol, which stands for a mean of the population, and a sigma. It's kind of a funny looking R that stands for your standard deviation of your population. And then they may ask you questions in a different manner. They would like to know the probability, the proportion, the percent. They could say the fraction of. With this instance, we're just going to talk about test scores. Scores below 110. To get a visual reference, let's draw a normal curve. I'm doing the best I can with my normal curves. They're not always the prettiest things. Now, in the middle, I'm always going to have my mean, and my mean is 100. And then I'm going to have 3 standard deviations above my mean. So add 15, add another 15, and add another 15. And now we want to go 3 standard deviations below as well. So let's subtract 15, and subtract 15. Now, when we standardize, because what I'm trying to do is find how much of my test scores are below 110. Well, 110 would fall in between the mean and the first standard deviation. So I'm going to standardize. So when I standardize, that means my mean goes to 0, and each of the standard deviations goes to 1. And then you'll have a formula for a z-score. And this is a given formula for the Virginia Standards of Learning on your formula sheet as x minus mu divided by sigma. Well, our x is our value of interest, which is the 110. Our mean was given to be 100, and our standard deviation was given to be 15. Do a little bit of computation and get 0.67. So on this scale, the standardized scale, I'm looking at 0.67. And our question is below. So I want to take my curve, and I want to find this shaded area below that value. Now, the mean represents 50% of our data, so I know that my answer is going to have to be more than 50%. And you can use your tables to find this value. I'm going to use the calculator, and I'm very specifically going to use a TI-84 Plus Silver Edition with a new operating system. And I'm going to be pushing second, and then the vars key, and then I'm hoping you can see that. I want to go to the normal CDF function, and you're always going to be using normal CDF. And notice it prompts you, it gives you a menu, lower bound. Well, if your curve is shaded on the left, which ours is, then we have an infinite lower bound, so we give it a very, very small number, negative 1e to the 99. That's a very small number. And then it says upper bound. Well, my upper bound is my 110. My mean was 100, and my standard deviation was 15. And I hit enter one more time. So the proportion, the percentage, the fraction of, and you might need, if it's percentage, you might need to put a percentage on the end, about 0.75 or 75% of the scores for this normal distribution are below 110. Now, one other way you could do this, go back to second vars, normal CDF, because we did calculate our z-score by hand, then I could put my z-score of my 0.67 as my upper value. My mean would go to 0, and my standard deviation would go to 1 because I had standardized. And there, notice my answers are a little bit different because my 0.67 was a rounded value. so this top one is more exact, but not a big difference between the two, about 75% for both answers.